हेलो मेरे पढ़ाकू बच्चों, आज हम स्टार्ट कर रहे हैं 3 डायमेंशनल ज्योमेट्री और उसमें सबसे पहले आता है डायरेक्शन कोसाइंस। डायरेक्शन कोसाइंस वी हैव ऑलरेडी कंप्लीटेड इन द चैप्टर वेक्टर्स, बस जस्ट वी हैव रिवाइज। सपोज is a 3 dimensional xyz axis is a thread, any ray from the origin O. This thread makes angle alpha from the x-axis, beta from the y-axis and gamma from the z-axis. As shown in this figure, say OP is a line segment making angle alpha from the x-axis, beta from the y-axis and gamma from the z-axis. And another line, say AB, parallel to same OP, then the direction cosines of this line AB is same as cos alpha, cos beta and cos gamma. Notation for direction cosines always L, M and N. L, M, N are the DCs of the line segment same AB, same as OP. But if we'll consider OQ, then the angles may be shifted to pi minus alpha, pi minus beta and pi minus gamma. Then these DCs are minus of L, minus of M and minus of N. Why? Because 180 minus theta, cos of 180 minus theta is minus cos theta. So element positive or element negative, these two are said to be direction cosines. Now direction cosines, if you have, how we convert it into DRs or DRs converted to DCs. DRs are the proportionate numbers. DRs are the proportionate numbers L by M by B, N by C. Suppose all these three equals to say K. Then L equals to AK, M equals to BK and N equals to CK. Correct? DRs, suppose XYZ is any point P. Then you know OP is the magnitude, that is R. This OL equals to X. Then simple trigonometry, what is cos alpha? Cos alpha is X upon R. This is nothing but L. It means similarly we can calculate cos beta equals to Y upon R equals to M, and the last cos gamma equals to Z by R equals to N. If we'll calculate the value, say x square plus y square plus z square, what we are getting? X square. X square means R square, L square, plus y square is R square, M square, and Z square is R square, N square. If we add all these three column wise, what we are getting? X square plus y square plus z square equals to R square is common. Inside the bracket what we get? L square plus M square plus N square. Correct? R square is what? If this one is the OP vector, then what is R? R equals to under root of A square plus B square plus C square, that is X square plus Y square plus Z square for this case. Hence X square plus Y square plus Z square is what? R square. So here we can write R square, L square plus M square plus N square. R square cancel out. Hence the most important thing, L square plus M square plus N square is always 1. Very important formula. Direction cosines ratio, direction cosines relation, L square plus M square plus N square is always 1. Now we consider the same relation to get one more relation between DRs and DCs. Here DRs are the numbers proportional to DCs. किसी भी एक लाइन सेगमेंट के लिए अगर मैं एक लाइन और बनाता हूं तो इन सब के DRs क्या होंगे, सेम होंगे। ये हो सकता है कि ये 1 2 3 है तो इसके प्रोपोर्शनेट 2 4 6, उसके प्रोपोर्शनेट 2 3 6, 4 3 12, 6 3 18. These are all DRs. Proportionate to main DCs. L के प्रोपोर्शनेट L equals to AK, M equals to BK and N equal to CK. But we know L square plus M square plus N square is 1. So substitute here. What we'll get? A square K square, B square K square and C square K square, that is equals to 1. It means K square is common. A square plus B square plus C square equals to 1. Or what we say? 1 upon A square plus B square plus C square is K square. So what about K? K is nothing but 1 upon root A square plus B square plus C square with plus and minus. Now when you know the value of K, we'll have the relation between ratios and cosines. What relation? Now we have L equals to AK. Hence, we can write AK equals to L, but K is already we have 1 upon root A square plus B square plus C square with plus and minus. This is the value of L. Similarly, if I want to calculate M, then plus minus B upon under root A square plus B square plus C square. And if we want to calculate N, plus minus C upon under root A square plus B square plus C square. That is the value of R. Correct? So most important thing is what is direction cosines, what is direction ratios, and the relation between them. For example, first we start with question number 1 of the same exercise 11.1. First question is the angles mixed with x-axis, y-axis and z-axis are given to you 90, 135 and 45. Find their DCs. So first we start with L, cos alpha, M, cos beta means cos 135, and last N equals to cos gamma, that is cos 45. Now you know each and every value. What is cos 90? 0. What is cos 135? 1 by root 2. And what is cos 45? 1 by root 2. These are the values of direction cosines L, M and N. And if you want to check L square plus M square plus N square, if you are getting 1, your answer is correct. One more sum. Find the DCs of a line which makes equal angles with the coordinate axis. It means all the angles are equal. Alpha, beta, gamma equal to say theta. It means what is cos alpha? Cos theta is L. What is M? Cos theta. What is N? Cos theta. All the three angles are same. But you know the relation L square plus M square plus N square equals to 1. Substitute here. Cos square theta 3 times because all three are equal. So cos square theta is 1 by 3. Hence cos theta equals to 1 by root 3. So what about the angle? Theta equals to cos inverse 1 by root 3 is the answer. Simple. One more sum. If line has the DRs, this time DRs are given. That is A, B, C. A is given minus 18, B is given 12 and C is given minus 4. Find the direction cosines. Question number is 3rd. DRs are given and we want to calculate DCs. Very simple. How we convert? The formula is L equals to A upon root A square plus B square plus C square. So substitute the values. Under root 18 square, 12 square and 4 square. What we are getting? Minus 18 upon under root 324. Just add rough column 144 and 16. 484. L equals to minus 18 upon root 484. That is L equals to minus 18 by 22 equals to minus 9 upon 11. Similarly, we can calculate M and N. So M equals to 12 divided by 22, that is 6 by 11. And third, N equals to minus 4 divided by 22, that is minus 2 by 11. These are the DCs of the line segment given where A, B, C are minus 18, 12 and minus 4. Now, suppose we want to calculate DCs of x-axis. The next important point is DCs of x-axis. X-axis means only this side, x-axis. Any line, suppose we put thread on x-axis, then this thread makes 0 degree from x-axis, 90 degree from the y-axis and 90 degree from the z-axis. So DCs of x-axis, cos 0, 1, cos 90, cos 90. Similarly, DCs of y-axis, 0, 1, 0 and DCs of z-axis, 0, 0, 1. Correct? Now the important point, suppose we have any point 2, 3, 4 in the plane and we want to calculate its distance from x-axis. What about its distance from x-axis? It means under root of 3 square plus 4 square, that is 5. Similarly, if you want to calculate its distance from the y-axis, it means 2 square plus 4 square. 4 plus 16, that is root 21. And in the same way, we can calculate the distance from the z-axis. These are some important questions for competitive exams. Now the next point is, if we have a line, say L, and any 2 points on this line, say x1, y1, z1 and x2, y2, z2. Suppose this line having DCs L, M and N. And we want to calculate the direction ratios of this line segment PQ. So, if we draw altitudes on x-axis, this line is making angle LMN, cos alpha, cos beta, cos gamma. It means what we say, suppose this gap is nothing but R under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. It means PQ cos alpha equals to x2 minus x1. Similarly, y2 minus y1 equals to PQ cos beta and z2 minus z1 equals to PQ cos gamma. These cos alpha, cos beta, cos gamma given to you for this line L, M and N. It means x2 minus x1 upon L is same as y2 minus y1 upon M is same as z2 minus z1 upon N equals to nothing but PQ, and PQ is what? R. Now what is the definition of direction ratios? Direction ratios are proportionate numbers to direction cosines. Since these are proportionate numbers, it means x2 minus x1 equals to A, y2 minus y1 is B and z2 minus z1 is C. So direction ratios of a line segment PQ are nothing but their difference, x2 minus x1, y2 minus y1, z2 minus z1. Now the next point is, if you have the coordinates, how we calculate DCs and DRs both. For example, say question 2, 4, 6 and 1 minus 9, 3. We want to calculate first DRs and then DCs. So first we start with the DRs. 1 minus 2, minus 9 minus 4 and 3 minus 6. It means minus 1, minus 13 and minus 3 are the DRs, and DRs always denoted by small a, b, c. These are the DRs. Now I want to calculate DCs. So DCs are minus 1 upon, minus 13 upon, and minus 3 upon. What we have completed in the last sum. Inside the root you have to write 1 plus 169, use rough column, 1 plus 169 plus 9, then 179 and 179. These are the values of DCs. Next is sum number 4. To prove that these 3 points are collinear, suppose A, B and C. So first we have DRs of AB. What are the DRs of AB? This minus this, second minus and third minus. These are the DRs of AB. Now what about DRs of BC? 5 minus, that is 6, 8 minus, that is 10, and 7 minus, that is 6. Now what is the conclusion? These two are proportionate. If you multiply by minus 2, minus 2, minus 2, it means it is clear that these two are parallel. These two are parallel, but since B is the common point, hence AB and BC are collinear. That means complete 3 points A, B, C are collinear. और अब हम आगे हैं last question of 7.1. A, B, C coordinates are given for this triangle. We want to calculate DCs of all the 3 lines. So first we start with line AB. DRs of AB are y2 minus y1, y2 minus y1, z2 minus z1. These are the DRs. If some number is common, we can cancel out because DRs are proportionate numbers. We can write it minus 2, and 3. And if we divide by the magnitude, that is R, you will get DCs. 4 and 4, 8, 8 and 9, 17. These are the DRs of the first line segment. Similarly, first we calculate DRs of BC. Second minus first, minus 5, so minus 4, minus 5, minus 6, and minus 2, minus 2. We can cancel out again by minus 2, and divide by minus 2. Divide by value of R. 4 and 4, 8 and 9, the same thing. These are the DCs. For the third, first we calculate DRs of CA. Second minus first, and second minus first. Check it again. Minus 5, minus 3, minus 5, minus 5, and minus 2 plus. Now again we can cut by 2. These are minus 4, minus 5 and 1. Divide by their value of R. 16, 25 and 1. Root 42, root 42, root 42 and root 42. These are DCs and DCs of the given question number 5. So in this way we have completed the exercise 7.1, in which the main object was what is DRs, what is DCs and what is the relation between these two. Correct? तो 3 डायमेंशनल स्टार्ट हो चुका है. वेक्टर्स जिन बच्चों ने थोड़ा कम करा हुआ है, पुराने लेक्चर्स देख करके वेक्टर्स को थोड़ा और अच्छा कर लें. क्यों? क्योंकि 3D में वेक्टर्स हम बहुत ज़्यादा काम में लेने वाले हैं. तो लॉकडाउन का आप यूज़ कर रहे हैं, धीरे धीरे पढ़ते जा रहे हैं, हम आगे बढ़ते जा रहे हैं और बोर्ड 2021 की तैयारी करते जा रहे हैं. मुझे आपके मार्क्स 2021 में बहुत अच्छे चाहिए, वही मेरे लिए सबसे ज़्यादा लाइक्स होंगे. गुड बाय, टेक केयर.